In our modern world, carbon dioxide, also known as CO2, is abundant in the atmosphere. It is primarily generated through the combustion of fossil fuels such as coal, oil, and natural gas for everything from energy production to transportation to industrial processes. Normally, Earth holds just enough CO2 to keep the planet's atmosphere stable and the climate regulated, but humans have been shifting this equilibrium by producing too much. This excess CO2 has begun making its way to the ocean and is making huge problems for the life that thrives under our seas. That is why we chose to focus on the UN Sustainable Development Goal of life underwater. When CO2 dissolves into seawater, it forms carbonic acid, H2CO3. That acid breaks apart into aqueous hydrogen and bicarbonate ions. These hydrogen ions are extremely harmful. They bond with carbonate ions, which are essential ions that would usually form the calcium carbonate ions that marine creatures like clams utilize to form shells or that coral uses to build its skeleton. In the past 20 years alone, coral diversity has decreased by around 20%. Total coral coverage has declined by half since the 1950s. This has had negative effects on all of the species that depend on coral for shelter and safety. The acidification of our oceans is a detrimental issue that needs to be solved. Firstly, CO2 emissions as a whole need to be decreased so that the ocean is not receiving mass amounts of CO2 anymore and can regain its balance. Alongside that, plastic pollution also needs to be reduced, as it can release CO2 into the ocean as it breaks down. The second side of this solution is attempting to fix the damage that CO2 has already done to our oceans. One strategy that we would like to propose for this is regulated large amounts of kelp farming. As kelp grows, it will help capture the CO2 in the water. Additionally, this kelp would provide a home for more marine life, increasing diversity. Another strategy that we would like to mention is taking coral samples from species going extinct and breeding them in labs. Then they could be transplanted back into the ocean, increasing the amount of biodiversity of the coral in our reefs. Ocean acidification is a huge issue, and it deserves the attention of the chemical community. Together, we can fight for a future full of diverse and happy marine organisms. Thank you.